Okay, engineering students, welcome back. I want to proceed on with where we left on representations of organic molecules. As you can see here, this is like a three-dimensional structure of a molecule, which I'm going to call methane. You can just say the black ball at the center is carbon, and then the white ones are hydrogen, and these are the bonds which are joined. As you know, in the organic chemistry, you are dealing with the bonding being covalent. Yeah, covalent bond is formed by the sharing of electrons. Yeah. All right. So this is a structure of methane, whereby there is the carbon and there is the 4 hydrogens. So this will be equivalent to carbon, hydrogen, 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 and hydrogen. All right. So there's something I want to show. What's going to happen if you're going to add a second carbon, a third one, a fourth one, a fifth, and a sixth one. But I think this type of illustrations are quite good, but in the box of the molecular model kit which I got, there may not be enough of this structure. So I got another illustration, but I can be able to have more of these atoms. So they're just illustration, but this is just a small, a different model kit, but they're just showing the same thing. Yeah. So as you can see, there is the black atom at the center, which I'm going to call the carbon, and then there are the hydrogens. So there are 4 hydrogens. Yeah. These are tetrahedral structure. So this is what I'm going to show here. So let me just try to see whether I can illustrate of something like okay, in this case, what I've done is I have added 1 extra carbon atom. So to try to illustrate this one, what you do is you get your structure like this, and then you remove one hydrogen. All right, and then I attach another carbon with the hydrogen. As you can see, there is a carbon, and then each carbon has got how many bonds? 1, 2, 3, and 4. So each carbon atom has got, like this one has got 1. Is it clear? 1, 2, 3, and 4. 4 bonds. Yeah. Each carbon has got 4 bonds. All right. So this is the structure of ethane. 2 carbon atoms, and then 1, 2, 3, 4, 5, 6 hydrogen atoms. So there is 2 carbon atoms, and then 1, 2, 3, 4, 5, 6 hydrogen atoms. By the way, I think it's important that we need to mention this, that there is a general mathematical formula that if you know the number of carbon atoms, which I call an N is the number of carbon atoms where N starts from 1, 2, 3 up to whatever number of carbon atoms. The number of hydrogen atoms is related to the number N. Yeah, by this one, H2N plus 2. Are you seeing that? Where N is equals to 1, 2, 3, 4, etc. So let us see what's going to happen. If I'm going to put N is equals to 1, I'm going to have C1, and then hydrogen, it will be 2, times 1 plus 2. So basically, according to body mass, yeah, you do multiplication first before addition now. So in this case, it will be 2 times 1 and then plus 2. So this will be what? So this will be 2 plus 2. So this will be C1H4. So in this case, if N is 1, it's normally taken silent. So this becomes something like CH4. So if there will be 2, it will be C2, and then hydrogen, it will be 2 times N is 2 plus 2. So this will be what? 2 times 2, that is 4 plus 2, that is 6, yeah? Okay, so this will be C2H6. So from this formula, CnH2n plus 2, you can be able to, if you know the number of carbon atoms, it is easy to predict the number of hydrogen atoms that are going to be attached to that structure. All right? So this is the structure of ethane. 2 carbon atoms and then 6 hydrogen atoms. So once again, this is the illustration. 2 carbon atoms and then 3 hydrogens, and 3 hydrogens making 6 hydrogen atoms. So let me see what's going to happen if I'm going to add another carbon with hydrogen atom. So I'm going to remove one of these hydrogens, and then I'm going to add another. I'm going to do what? Okay, so this is the structure which I had. Let me get it back so that you can see what I'm doing. Yeah, this is what I had as methane. So I'm going to remove one of the hydrogens which is nearer to you. Yes, and then where it was left, I'm going to put a carbon with the hydrogens. Yeah, can you see that? Now look at the ones at the center. Can you see well? This is carbon, 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 and then there is a carbon with 3 hydrogens, and 3 hydrogens. Can you see that? Now, this structure may appear complicated, but something which you need to know is this, is that the bond angles are all 109.5, and the structure at each point is tetrahedral. Let us see, for example, if I was to remove, if I was to detach here, can you see here? I'm going to detach here, and you see this is a what? This is a tetrahedral. Can you see? It's a tetrahedral. If I was to look at, okay, this is what I'm returning it here. So if I was to remove the one at the end, probably, and the one at the end here, if I've got the one at the center once again, it's still a tetrahedral. Can you see? It's still a tetrahedral. So let me join it back here. That tetrahedral and this tetrahedral. Can you see that? Yeah. It may look complicated, but this structure for the 3 carbon atoms is like saying carbon, another carbon, and then another carbon. And then on each carbon, I'm adding a hydrogen, 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 and a hydrogen. Wow, that's simple. It's that simple. Yeah? So if I use this formula, you're going to get what? C3, 1, 2, 3. So how many hydrogens are you going to get? It will be 2 times the number of carbon atoms, it is 3, and then I'm going to add plus 2. Yeah? Yeah? So this will be C3. So hydrogen will be what? So according to the body mass, you do what? Okay, perhaps I should put it like, I should put it like this, and I should put it in bracket like this, yeah? So that it will be what? 2 times 3, that is 6, plus 2, that is 8, yeah? Can you see that? So 1, 2, 3, 4. Okay. Let me count them sequentially. 1, 2, 3, 4, 5, 6, 7, 8. Can you see that? All right. So this is the structure. Now there's something which is happening. When it was something like ethane, it was flat, but now you can see there is something like a bend here. Yeah. So this is 3 carbon atoms. Let me see what's going to happen if I'm going to add another. Okay, that's what I have. Let me see what I'm going to. If I'm going to add another carbon atom, of which can you see this is what I have? Yeah. So to add another carbon atom, what I'm going to do, I'm going to remove one of the hydrogen. Perhaps I remove the one which is nearest to you. Sorry. Let me remove one which is nearest to you. This one. Can you see? I've just removed that hydrogen, and then I've added another carbon atom. Can you see that? Can you see what I've done? So the structure has got what? Has got there is a carbon black ball 2, 3, and 4. Hey, what is happening to the structure? Look at the way the black balls are oriented. Can you see? There is that black ball, that one, and that one. You're now starting to see something like a zigzag, yeah? Can you see? There is that zig, zag, zig. Can you see? Can you see that zig, zig, zig? So this, if I'm going to add a 4 carbon atom, even though in the structure I'm drawing it like this, can you see that? But in reality, I can see something like a zigzag structure, yeah. So this is similar to like there is a carbon here with the hydrogens here. Then there is something like there are 2 hydrogens at the top here. Then there are 2 hydrogens at the bottom here. Then there are 2. Okay. So if the ones for the carbon atoms, I'm going to show it in red. Can you see that? Can you see that? So there is 1, 2, 3. So there is this zigzag manner. Can you see that? Can you see that? It looks like a zigzag. 1, 2, 3, 4. Let me add another carbon atom, yeah? So this is 1, 2, 3, 4. Perhaps I'm not going to remove that hydrogen, and then I add another one here, another carbon atom. Can you see what I'm getting? Yeah? 1. Okay, let me move a little bit further so that you can see well. 1, 2, 3, 4, 5. Now can you see the zigzag? It's like top, bottom, top, bottom. Can you see? Zigzag, zigzag. So if I'm going to add another one, I can get another. I'm going to get something like a zigzag pattern. So what does it tell you? Yeah, okay, this is 5 carbon atoms. Let me add another one, and then you're going to see us once again. Yeah, let me add another one, and then you'll see. Okay, let me. So this is what I had as showing what. Let me put it like this, well, so that you see exactly. So there is zigzag, zigzag. So I'm going to remove one of the hydrogens, and then I put a group here. Can you see that? So can you see what I'm getting? So this is 1, 2, 3, 4, 5, 6. Can you see zigzag, zigzag? So I'm going to remove one of the hydrogens once again, and then I put another another group again. Sorry. So this is what I have, and then I'm going to remove one of these hydrogens, and then I put a group here. So this, how many black atoms can you see here? 1, 2. Okay, let me point it here from this other side. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So let me add a last one, a last group. Sorry, let me add a last one. I think it will get a little bit long. So let me add another group here, and then you see now. All right. So let me put it the way so that you'll see how the black atoms are looking like. Can you see here? Look at the way the black balls. Can you see there is something like a zigzag, 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 zig. Can you see that zigzag? Can you see? There is zigzag, zigzag. Yeah. Can you see it? Forget about the hydrogens, the way they are looking like. But I want you to focus on the black atoms, which is what I'm calling the carbons, because there is a shorthand which the scientists have come up with by just saying, hey, let us just say, let us do what? Let's try to say, okay, let's assume the hydrogen atoms are there, but let us focus on the carbon atoms. These are how many? 1, 2, 3, 4, 5, 6, 7, 8. It's like an octane. Can you see that? This is an octane. Yeah? This is 8 carbon atoms. So if I'm going to focus it, can you see it can be zigzag from the top, or it can also be zigzag from the bottom? Yeah? Let me put it like this. Yeah? In this case, it is bottom up, bottom up, bottom up, bottom up. Or in this other case, it's also the same thing. Top, bottom, top, bottom, top, bottom, top, bottom. Can you see that? So if I've got like this, what I'm going to get like this. If I'm going to be looking at the carbon atoms, I'm going to get 1, 2, 3, 4, 5, 6, 7, 8. Can you see that? If I may show it like this, yeah? So there is what? There is carbon number 1, okay? Number 2, number 3, number 4, number 5, number 6, number 7, number 8. If I was to number them there, you're going to get number 1, number 2, number 3, number 4, number 5, number 6, number 7, and then number 8. Wow. Can you see that? All right. Now, this structure assumes that you know that that at the end, if there is no other atom attached to this other side, the carbon at the end has got, how many hydrogens can you see there? Has got 3. The same thing about the one at the end here. Can you see the one at the end? Yeah. The one at the end has got how many hydrogens? 1, 2, 3. Okay. Now let us look at the ones at the center. The ones at the center. The one which has got a carbon here and a carbon here has got how many hydrogens? Has got 2 hydrogens. Yeah. 2. This other than 2. This other than 2, 2, 2, and 2. Can you see that? Has got like that. So this structure assumes that in this shorthand notation, if you're going to see this zigzag manner, it tells you that this carbon has got how many hydrogen atoms? 3. This one has got 2 hydrogen atoms, 2 hydrogen atoms, two hydrogen atoms, two hydrogen atoms, two hydrogen atoms, two hydrogen atoms, and then this one, 3. Can you see that? Can you see? All right. So this is what I have here. Okay, let me show it well. Can you see well? Good. Oh, okay. Or perhaps I move it here. The one at the end has got 3 hydrogens. The next one has got 2. The next one has got 2. The next one has got 2. The one which I'm holding here has got 2. This one has got 2. The next one has got 2. And the one at the end has got 3. Are you going to remember that? Yeah? So the scientists, they came up with this shorthand notation. This one is called, what is this word? Bond line structure. And then in this bond line structure, what it does is it just simplifies the structure. I mean, just simplifies the illustration of the structure. Now, this is similar to this one here. Can you see here? Can you see how tiresome it will be looking like? Yeah. Let me redraw it. 1, 2, 3, 4, 5, 6, 7, 8. So this one at the end has got 3 hydrogen atoms. The one at the center, the next one has got 2 hydrogen atoms. The one has got 2 hydrogen atoms. The next one, 2. The next one, 2. The next one, 2. The next one, 2. And then the last one has got 3. Can you see that? 1, 2, 3, 4, 5, 6, 7, 8. Wow. Yeah. So I hope now you'll be able now to relate this structure, which is linear, it is 2-dimensional, and then there is this bond line structure, which is like it is easier to show it like this, but you have to understand the assumptions made. The one at the end, it's an illustration of, it's an illustration of carbon containing 3 hydrogen atoms. So this one at the end, the one which I'm showing here, is carbon with 3 hydrogen atoms, and the one also at number 8, can you see that part of the structure is that carbon with 8, I mean with 3 hydrogen atoms. All the rest here have got 2 carbon atoms. Yeah, I mean 2 hydrogen atoms. Now, would like to do something. For example, if I've got, if I've got a structure like this, yeah, and then what I want to do is probably on carbon number 1, number 2, number 3. Let me try to replace one of the hydrogens with a carbon atom. I want to replace it with a carbon atom. Yeah. So let me just try to put in probably a group like this. Okay. Or do I use? Okay. Let me just try to. Okay. I'm just trying to show. Okay. This is what I have. So. Okay. Can you see one? All right. So what I want to do, I want to remove one of the hydrogens, yeah? Yeah? And then I've added, I've added a carbon. Okay, I'm going to remove that hydrogen. Can you see what I've done? I've now added, I've just put a different balls so that you can see from the blue color that it's something which I've now added. Can you see? That is the new structure. What can you see there? Yeah, can you see? Can you see one? So what you had is, you had your zigzag manner, and then on 1, 2, carbon number 3, there's one of the hydrogens, and then there is a carbon with 3 hydrogen atoms. Now, this one which I've now added, the one which I've added, it has substituted a hydrogen. So this group which I've added, which has got a carbon with 3 hydrogen atoms, it is called a substituent. What is that word? It's called substituent. It's called a substituent. I have substituted a hydrogen, and then I've put a carbon with a hydrogen atom. Yeah. So that is similar to the fact that I had one carbon number 3. So I've replaced one of the hydrogens. So I've replaced that one with, maybe I put a carbon here with a hydrogen. Perhaps to show you the same thing here, let me show it in blue. Carbon with a hydrogen, and then with a hydrogen. Can you see what I've done? Yeah. So this is now my substituent. Yeah. If it will be similar to what I have here, it will be on carbon number 3. Yeah. So there's carbon number 1, number 2, number 3. It means that on carbon number 3, I'm going to do what? I'm going to put a bond here. Can you see what I've done? Can you see what I've done? It was 1, 2. On number 3, I've put a line there. So that tells me what I've done. Okay, let me show you. So on this zigzag manner, the hydrogens are assumed to exist, but if we are going to show carbon atoms, it must be shown explicitly. So this is what I had. It was carbon number, let me just show it exactly the way you can see here. It was 1. Okay, can you see 1? 1, 2, 3, 4, 5, 6, 7, and 8. What I've done is on carbon number 3, I've added a group with a carbon with 3 hydrogen atoms. Now, this one which I've added has got 1 carbon atom. So this substituent, its prefix will also start with a meth. But yeah, so the group which I've added has got 1 carbon atom, so it will be called the prefix will be meth. Yeah. But to distinguish it from the name of the alkane, that group which I've added as a substituent, I'm going to add the word YL. So as substituent, the prefix ends, the prefix for the substituent ends with YL. So that tells you, if you have a substituent with 2 carbon atoms, it will be eth, and then it will end with YL. So it will be called what? Ethyl. If it is 2 carbon atoms, the name will be eth, and then I'm going to put YL. If it will be 3 carbon atoms, it will be prop, and then I add YL. If it will be 4 carbon atoms, it will be but, and then I add YL. Sorry, YL. Can you see that? For our case, though we can get to substitute with 5 carbon atoms, 6 carbon atoms, but in our case we are only going to study the substituents containing up to 4 carbon atoms. Yeah, they're going to contain what? 4 carbon atoms. So I think the board is a bit filled, so I think we'll just take a short break, and then we'll follow up from this structure which is containing 8 carbon atoms, and then there is a substituent on carbon number 3. Yeah, I hope you really understood. It's not hard. is quite simple, and you're just going to follow up from this bond line structure. Okay, thank you.